Okay, so this is question 21 of the final exam review. So we're supposed to construct a binomial probability distribution. And so what we're going to do is we're going to go into stats, calculators, and then binomial. And we input our n equals 10 and our p equals 0.8. And we just have to go through, change that to an equal sign. And we start with 0. We type that in. And then we go to 1 and type that in. Then we go to 2 and we type that in. Let's see. So we can round that one to 1. Okay, and now, personally, I think this question is really dumb because what it's going to do is it's going to ask you to compute the mean and standard deviation using this equation, and then in part C, it will ask you to compute the mean and standard deviation using a different equation, and you're going to get the same answer, and it's just trying to show you that both equations work. But this one, I don't like it. It's hard, and don't use it, okay? So when you go to the formula sheet, remember we're doing a binomial. And so down here, I think it's chapter 8. No, it's not. Here it is. Chapter 6, the mean and standard deviation of a binomial random variable. So that is what we are finding. So use this, please. These are the equations I believe that it gave you. Ignore them. They're long and dumb, and you get the same answers using this. So we're going to go ahead and do that. So for the mean, we are going to do n times p. So 10 times our probability of 0.8. This should be our mean. The standard deviation, once again, it looks like this. It's the square root of n times p, which is the same thing as our mean, times 1 minus p. Okay? So we already have 8, and now we need to times, so that was our n times our p. So then we can times 8 by 1 minus our proportion, and then we need the square root of that number. And then see, now you're going to do that same thing right here. If you want to try and do these equations, you're more than welcome to. Remember, this means the sum. But if you have the sum of all of these probabilities, it should just equal to 1. So anyways, it's the same thing. It's just a more complicated way of writing it. So I can just put in that 1.26 that we already found, and it's the same one. Now we're going to find the distribution, and so we'll go back up to here, and we see that our highest point was at 8, and then it's a little bit higher at 9. And so we want something that is like that. Highest point at 8, a little bit higher at 9, right here. And then remember, it's where the tail is which way it's skewed. And so it's skewed left because the tail is to the left. And that is how you do this question.